Right, good morning, Year 12. So, it is currently Tuesday. So some of you will be in school, which is where I am, even though I'm on this video at the same time. I mean, how is that even possible? So the last topic of the course was the parametric integration. So what I'd like to do now is start doing a bit of revision, but also keeping in mind that integration is one of the most challenging things on the Year 2 course. So some more work with that. So I'm going to set 4 questions in a row, and I'm going to set some integration questions. So if you could pause each one, have a go, and then come back to it and check the answer. Right, so number 1 here. So we've got an equation. It passes through this point here, x and y, and we've been given the differential, and we're trying to find f of x. Okay, so we're going to need to integrate this. So f of x must be 3 over 8 of x cubed over 3 minus 10x to the 1/2 over 1/2 plus x plus c. So let me simplify that. Cancel those 3's. X cubed over 8 minus 20x to the 1/2, plus x plus c. And then I can use this term here, this point, sorry, to calculate this. 4 cubed, 64 over 8. 8 minus 20, square root of 4, so that's minus 40 plus 4 plus c. So 8, 12, 12 minus 40. 12 minus 40 is minus 28, and then 25 plus 28 is 53. So constant is 53, and so the function, which you must rewrite at the end clearly, x cubed over 8 minus 20x to the 1/2 plus x plus 53. What do you say? It's quite common that students do the integration step and then forget to use the point to calculate the value of c. So just make sure you don't slip into that possible error. Right, so find the equation of the normality curve again at this point. Okay, so we can get the equation, get the value of the differential of the tangent by putting 4 into the differential here. So that'd be 3/8 of 4 squared, which is 16, plus 10 times 1 over the square root of 4, which is 1 over 2, plus 1. So what's that going to be? 16 over 8 is 2. 6 plus 5 plus 1, which is 12. But I think I've made a mistake because that's a minus. So let me just fix that up. 6 minus 5 plus 1, which is 2. And so, of course, the gradient of the normal is minus 1/2. So we can do y minus 25 minus 1/2, x minus 4, times by 2, 2y minus 50, minus x plus 4. So x plus 2y minus 54 equals 0. There we go, question 1. Oh, that was a spare space for me to do more question 1. Question 2. So this is a circles question. Okay, so it looks like a fairly straightforward beginning. We've got the equation of the circle. We need to do the completing the square step. So part A here, we're going to be doing x plus 1 squared minus 1. Plus, make sure you're not just watching this or copying it down. You need to be actually doing it yourself in advance. So we've got x plus 1 squared plus y minus 3 squared. That's minus 50. So that's equal to 50. So part B, the centre of the circle must be at minus 1, 3. And part 2, the radius is the square root of 50. It specifically requests it in this format. So that's root 25 root 2, which is 5 root 2. Okay. This is the best bit. The point P with value 4k lies in the circle. Find the value of k. Okay, well this is x and this is y. So if I substitute x and y into the equation, I could do it in, I'm going to do it straight into the completed square form, and that's going to be easier. So 4 plus 1 squared is 5 squared is 25, plus y is equal to k, so that's going to be plus k minus 3 squared equals 50. So I'm going to take that 25, I'm going to square root, and I'm going to add 3. So I've got 5 add 3, which is 8, but I've also got minus 5 add 3, which is minus 2. So I've got these two possible values for k. Okay. Part D. So the points Q and R also lie on the circle. And the length from, okay, this is a bit confusing. I'm going to draw a picture. Always draw a diagram if things get a little bit confusing. So here's the center of the circle. That is the point minus 1, 3. So Q and R lie on the circle, and the length of the chord is this one. Let's just pop Q and R on the circle. Let's put Q there. It could be anywhere, doesn't matter. R there. Okay, so that is a length of 2. The length of the chord is 2. Calculate the shortest distance from C, which is the center of the circle, to the chord QR. Well, the shortest distance is the perpendicular distance. So if we draw a line that goes directly there, perpendicular, there's a circle theorem, of course, that says that a radius bisects a chord at 90 degrees. And because that is perpendicular, the shortest distance, that must be 1, and that must be 1. Now we're trying to find this length of this chord here, which I'm going to call x. Now I don't know what x is, but I do know that if I create a right angle triangle by drawing a radius in there, that will of course be 5 root 2. And so it must be true that 5 root 2 all squared equals x squared plus 1 squared. Now if we square all that, we get 50 like we did earlier. So 50 minus 1 equals x squared. So that's obviously 49. And so x is equal to 7, not minus 7, because it's a length. Okay, good. Next one, we're whipping through this, aren't we? Next one, that's more space. Right, so an integration question, it's an exam question. Move over there. Find the value of that. Okay, so just run through some things that we might look at. So we could write it like this to effectively check for an inspection method. Okay, so an inspection method is not going to work because that is not any multiple of the differential of that. It's got too high a power. So that can't work. The top cannot be the differential of the bottom. So we can't use an inspection method. We can't use a log method. So we could try and do it by parts. This could be a by parts question. It looks messy. That's an x cubed. It could be 3 iterations, which I don't really want to do. So could try using a substitution. And a good substitution would be u is everything which makes the bottom bit a bit difficult, like that. You could just do the 6 minus x squared, but doing it this way, you're not going to get difficult powers. As I say, a substitution is not unique. So I'm going to go for, rather than differentiate as it is, I'm going to change it to u squared, and then I'm going to use some implicit differentiation to get that, and then that will give me 2u du equals minus 2x dx. So if I cancel the 2's, minus u over x du equals dx. I'm going to leave that x there because I can probably deal with it up here somewhere. I'm going to need to switch out some limits. So u squared is 6 minus x. U is the square root of 6 minus x squared. So x is 2 or 1. So 6 minus 4 is 2. So u would be the square root of 2. Or 6 minus 1, u would be the square root of 5. Right, so let's try and put this all together. So I've got, let's call this I. Right, I is, I'm going to put the u limits in. Got root 2 at the top and root 5 at the bottom. Root 2 and root 5. I'm going to change that top bit. I'm going to imagine the x cubed is like an x squared x. And that's because I can see that I need 1x to cancel with that x. So the x squared is 6 minus u squared from here, all divided by a single u. Of course, I've still got the x there. And then I've got the minus u over x du. So that x cancels with that x. And that u cancels with that u, which leaves me with a minus. So if I put that minus in, so I've now got root 2 and root 5 u squared minus 6 du. So what I've done there is I've used that minus there to multiply that by minus 1. There's not particularly any point, but do bear in mind that at any time you can switch the limits by timesing through by minus 1, which you might want to do here because root 5 is bigger than root 2, but it doesn't really matter. So I've got u cubed over 3 minus 6u between root 5 and root 2, which is going to give me root 2 cubed, which is 2 root 2 over 3 minus 6 root 2. No, silly computer. Minus, put the 5 in, so root 5 cubed is 5 root 5. So I've got 5 root 5 over 3 minus 6 root 5. Okay, so altogether here, that over 3, that's 18 over 3 root 2. So 2 minus 18 minus 16 over 3 root 2 minus 6 over 3, that's again minus 18. That's 5 minus 18, so that's minus 13 over 3 root 5, which in the end, double negative becomes a plus. So I've got 13 over 3 root 5 minus 16 over 3 root 2, and they are both rational. Okay, and then one more. So we've got a parametric one here. 9 marks. Let's see if we can do it in under 9 minutes. So pause this here. Have a go. Right, so to find this region, we need to be, I'm going to call it R. We need to be integrating y with respect to x between x limits, which in this case will be the integral between a 0 and a half of cosec t with respect to x, which we can't do, of course, because it's a t term. So we're going to need to use dx by dt, a bit like a substitution. So So differential of cos is minus sine, but we've got the 2 there. So we've got minus 2 sine 2t. We're going to need to sort out the limits as well. So we've got when x is equal to 0, 0 is cos 2t. So we're considering our cosine graph, just like that. That's pi on 2. So that occurs where 2t is pi on 2. And so t is pi on 4. So that's one of the limits. The other limit is x equals a half. So half is cos 2t. And we know that we get a half when we use from the table pi on 3. So 2t is pi on 3. And so t is pi on 6. So if we put all this together now, we've got the region is the integral. So I'm coming back from this step here, but I'm putting in the limits, I'm putting in the replacing the dx. So x is 0, gives me the pi on 4. And x is a half, gives me the pi on 6. So again, I've got the smaller value on the top, but you do need to stick with the original direction of the limits. And then I've got cosec 2t, so I've got cosec 2t, which I'm going to write as 1 over sine t. Right, let me just write it out first. I don't want to lose anyone. So I've got a cosec t, and then I've got this minus 2 sine 2t. Minus 2 there. So that's replacing this with a dt there. Okay. So I'm thinking, can we simplify that? So it's minus 2, and it's 1 over sine t. And this is, of course, 2 sine t cos t, double angle. Which means that that's the dt, of course, cancels with that. So ultimately, I've got minus 4 on the outside. No, not 4. Minus 6. And I've got just a cosine t remaining, which I come up here, which is minus 4. Let's put a square bracket there. So cosine t integrates straight into sine t between pi on 4 and pi on 6. And the sine pi on 6 gives us a, gosh, it's really tempting to write the smaller number on the bottom. Pi on 6 gives us a half, minus pi on 4 gives us root 2 over 2. So we've got minus 4 times a half is minus 2. And then minus 4 times minus root 2 over 2 gives us plus 2 root 2. And there we go. That is the value of r. Good. Okay, so there's the 4 questions. I've also attached a year 2 integration practice paper. I've put some answers with that as well. And I would just like you to do these 5 questions. These are also not the last 3 questions. So 1, 3, 7, 8, 9. There's 5 questions. This is the lesson schedule that I uploaded to the classroom last week. And just to be clear, so we've now Monday. I put that lesson there last week. The Tuesday lesson was cancelled. That's fine. The Thursday lesson, the exam practice, was set. That is, of course, due. The Tuesday, the 23rd, is now this lesson, which is some integration revision. Of course, the lesson, look at my planner here. the lesson on Wednesday is cancelled. Of course, some of you will be in school today, so you'll be catching up with this. So, hence the Wednesday cancellation of the lesson. I'll make sure the deadline on this work is reasonable also. And then we've got some exam practice on Thursday. And then as we go into the following week, where we've got the academic sessions, that's the exam week. So Mr. Allen, as I've written here, has got you block A on the Monday the 29th. So he will be giving out the exam papers. I will be collecting the exam papers in the following week in my session. The exam papers is a complete set. So we've got Pure Maths 1, Pure Maths 2, Stats and Mechanics. So that's 6 hours of exams, but all lessons that week for maths will be used for the exams. So I won't be delivering my 3 lessons. Mr. Allen won't be delivering his, how many lessons he has, and neither will Mr. Brown, and neither will Mrs. Randauer. And we really want you to treat these exams as a proper, do them in exam conditions, give yourself the correct amount of time, sit them in one sitting, all the things that you do in an exam, because if you waste these exam papers, given that there are only a limited number available, it will be a great shame. And just to bear in mind that for staff, the deadline for UCAS grades has already passed by the 7th of July. We are not using these for UCAS grades, so there is no advantage to cheating. If you do cheat, you're going to set yourself a big disservice. So no checking your notes, no looking anything up. You can do it or you can't. This is not a rod to beat you with. It's we need understanding about how you are, what your knowledge is like in the different topics, because we need to plan for next year. So please do these tests responsibly. Right, okay, I'm going to stop the video there. You get a strange minute whilst I flick around.